In this last graphing example, we're going to use the table to help us graph y equals x to the third power. Remember that anytime we plug in x values for x, we want to plug them in using parentheses. So in this case, I have negative 2 to the third power. Do not confuse this with negative 2 times 3. This is negative 2 times negative 2 times negative 2, 3 times. So negative times a negative is a positive, and then a positive times a negative is a negative. 2 times 2 is 4. And 4 times 2 is 8, so negative 2, the quantity negative 2 to the third power is negative 8. My first ordered pair is negative 2, negative 8. The quantity negative 1 to the third power, negative times a negative is a positive, times another negative is a negative, and 1 times 1 is 1, times another 1 is just 1. So this ordered pair is negative 1, negative 1. 0 to the third power, 0 times 0 times 0 is just 0. So this one goes through the origin at 0, 0. 1 to the third power is 1 times 1 times 1, which is just 1. Do not confuse this with 1 times 3. This is 1 times 1 times 1, which leaves us with the ordered pair 1, 1. And then the last one, the quantity 2 to the third power. Again, don't make the mistake of doing 2 times 3. That's a common error. We want to make sure we're doing 2 times 2 is 4, times another 2 is 8. And so this ordered pair is 2, 8. I'm going to graph these points on my coordinate plane over here. Negative 2, negative 8. Negative 1, 0, 0. 1, 1. And 2, 8. When I do that, I get this, it's another nonlinear function. And when I connect all my points, I want to connect my graph so that my arrows go off my coordinate plane system here. And I get kind of this squiggly little looking function. I'm going to label my points negative 2, negative 8, negative 1, 0, 0. 1, 1, and 2, 8. Then I'm going to label my line at either end, one of the arrows. I'm going to label my line with the function y equals x to the third power, since that was the equation that we graphed to get this function. And then how is this graph different from examples 1 and 2? I want you to use your own words to fill this out. So I'm not going to write anything, but I want you to write something here for how is this different than examples 1 and 2. We talked about in examples 1 and 2, the x squared makes this U-shaped parabola. When you have x to the third power, it's going to make this shape every time. It's going to make this squiggly shape every time. It might be on a different spot in the graph, but it's always going to make this same shape. And so definitely when we're looking at what's different, we're talking about the shape here is what's the biggest difference between the two. Example 3 and example 1 both go through the origin. They both go through that middle point of our coordinate plane system. But x to the third is definitely a different shape. And so in your own words, I want you to write that there at the bottom.